Hello everyone, welcome back to our third lesson of AND behavior. This is gonna be the last lesson of this topic, AND behavior, and we are going to use something we mentioned before to generalize some conclusion, some pattern of using some key factors of the polynomial to predict the AND behavior. And this time we are not using the graph itself. But before we start the lesson, let's quickly review some key terms we mentioned before about the degree and the leading coefficient. So for degree is 1 to describe the highest exponents of the polynomial. So as we can see, it's something like, for example, if we have a polynomial is 3x to the fourth minus 3x to the third power plus 7x and minus 9x squared minus 11. So no matter how many terms we have here, we always look for the highest exponents. For this case will be 4. So that's why degree is 4 for this one. And for leading coefficient, we are still going to focus on this one too. And leading coefficient is the coefficient in front of the term of in front of the variable with the highest degree, or with the highest exponent, as you say. So for this one is, since 4 is the highest degree, then 3 is going to be the leading coefficient. And the reason we call leading is actually when we reorder the terms to write the whole expression in standard form, and since it's the highest degree, so it's always stand in the very front in the first term, so we can also just use this idea as a leading coefficient. But do not give the wrong impression saying, oh, the leading coefficient is always the first coefficient. That will be wrong. The reason is, let's check this simple polynomial here. We have 3, 4, 5 as exponents, and the highest degree is 5, so that's why the leading coefficient is going to be negative 11 for this case. So that's why be careful. It's not always for the first term, unless you rewrite it in standard form, so you can, use a leading coefficient as that concept. Okay, so after these two terms review, we are going to start talking about how do we, what actually the pattern we can use to predict the end behavior of the polynomials. Okay, so to save our time, we are going to use 4 graphs here. And also, again, I don't want to make such a long video. Probably you already lost the interest to watch it. So there are 4 graphs here. As you can see, we also have the expression, the function equation attached to the graph. And for each one, we are going to check, is this leading coefficient positive or negative? Is degree even or odd? And then what is end behavior you can observe from the graph? That's something we are going to do. And you can definitely just pause the video and just check the first 2 or check all of them about what your answer for each question, and then you compare yours with mine. But the other thing I want to remind you is, to save the time, we are not going to write down the end behavior for each one. We will only write down the end behavior for the first one, and the other we just have a quick observation. So let's check the first one. The leading coefficient, as we see, this is the highest degree is 3, and this is 2, so it's 2, and it's indicated is positive. And degree is 3, which is odd. So as we observe here, end behavior is like 1 up, 1 down. 1 up is right up. Okay, let's see, right up, left down, right? So what happened to this? And when we write down, our math language is going to be as x approach to positive infinity, y is growing, right? Y is going up, so you can see y is approaching positive infinity. And for the left part is x approaching to the negative infinity. The y is down, so that's why is y approaching to negative infinity. So that's what happened to the end behavior for this function. Okay, let's move on to analyze the other three. So leading coefficient, as you can see, everything here is already written in the standard form. The highest degree is 5, which is also odd. And leading coefficient in front of this negative 3. So is for when we look for the right side is actually going down. So right down. And for the left side is actually going up. So it's left up. As you can see, if you write down the behavior, then it's look like this way then. So right down, left up. So for the number 3, the leading coefficient, as you can see, is the highest degree is 4. So this time is even. And then leading coefficient is -2, which is negative. It's obvious, right? So for this one, is right side going down, left going down. So you know what, since it's even, let's write down this and behavior too. As x to the approach to the positive infinity, since y is going down, so is negative infinity. As x approach to the negative infinity, and y is actually approaching to negative infinity too, because it's both going down. For the last one, the leading coefficient, as you can see, there's no number, so it's actually invisible 1, and it's positive. And for the degree is 6, so it's also even. And you can see they actually, no matter how many curves you see in between, but end behavior will only focus on the ending part. So that's why for this one we can see is right up, right, left up. They both up. So that's why it look like this one. Okay, so we're going to stop here, and we can, I actually want you to pause the video to figure out what actually the pattern you notice, and then we are going to use a table to write down our conclusion. So some of you probably already figured out. You did notice that when degree is odd, this is actually going to the opposite direction. And when the degree is even, they both going to the same direction, but sometimes it's up, sometimes it's down. Then when it's going to be up is actually depends on the leading coefficient. When they have positive, they both going up. When they have negative, they both going down. So that's why since we need to consider two key terms here, two factor, leading coefficient, I just use LC here, and also degree. So we are going to make a table. So, and one of the table here, we are going to focus on the degree. And for this case, we are going to focus on the leading coefficient. Probably it's not a good idea to draw like this, but let's just, focus on here. And what happened in the box here is actually talking about end behavior. So when degree is even, let's write down here. When degree is even and when degree is odd, we are going to separate this situation. And then we are going to check what happened when leading coefficient is positive, what happened to leading coefficient negative. And what happened in between is going to be our end behavior. So when degree is even and also leading coefficient is positive, as we can see, they actually both going up. So that's why it's left up, right up. So we can see as x approach to positive infinity, y is approach to positive infinity. As x approach to negative infinity, y still going to positive infinity because it's both going up. But when it's even, but the leading coefficient is negative, they both going down. So that's why is x approach to the positive infinity, y is approach to the negative infinity. But and when they to the negative infinity, y still goes to negative infinity. But for the odd part, we know it's going to be opposite. So when leading coefficient is positive, we know it's left down, right up. As you can see, the first one, left down, right up. So that's why we can write down is as x approach to positive infinity, y approach to positive infinity because it's on the right side. And as x to the negative infinity, y is approaching to negative infinity. This is exactly same as x. And when leading coefficient is negative, then it actually changes, is left up, right down. So that's why is x approach to the positive infinity, y is actually going down, become negative infinity. But when x is approach to negative infinity, y is approach to the positive infinity, which is exactly the opposite direction of x, which we can see from the second one. Okay, so that's actually our final conclusion here. So we use degree, even or odd, and we use leading coefficient, positive or negative, to predict our graph. So this case, you can also play with this pattern. You can just create a random polynomial, and then you just predict the end behavior. And later you can use decimals to draw the graph to see if you actually have a correct prediction. That's the pattern we actually finally have for end behavior. For when we use this pattern, it's going to be way much easier for us to predict all kinds of things. And the good part is we can use this end behavior to predict the very draft graph of the polynomial to analyze how they look like. Okay, that's something I want to share with you today. I hope this video is helpful. Thank you so much for watching this video. See you soon, everyone. Take care.